All right, let's talk about making our database work a whole lot smarter. Today, we're diving into a really powerful SQL command. It's a simple little tool that can save you from a world of headache, especially when complex tasks go sideways.
You know the feeling, right? You're running a big, multi-step script. The first few parts go off without a hitch, and then boom, step 6 hits an error. So what happens now? Does all that perfectly good work from the first 5 steps just get thrown away? It's a super common problem. And lucky for us, there's a really elegant solution.
So, here's our game plan. First, we're going to quickly cover the all-or-nothing problem with standard database transactions. Then, we'll see exactly why that can be a pain. After that, we'll introduce the solution, the Savepoint command. We'll see how it works with a real example, and then we'll wrap it all up by talking about why this makes your applications so much stronger.
Okay, so before we can really appreciate why Savepoints are such a game changer, we have to get on the same page about the absolute bedrock of database integrity, the transaction.
The classic example is a bank transfer. Think about it. When you move money from savings to checking, it's actually 2 separate operations, right? One debit, one credit. A transaction wraps them up into one single package. This guarantees that either both things happen successfully, or if anything at all goes wrong, neither of them happens. I mean, you'd be pretty upset if the money left your savings but never actually made it to your checking. And that means a normal transaction really only has 2 endings. If everything's perfect, you commit, and all your changes are locked in for good. But if even one tiny part fails, you roll back. And that means the database zaps back to the exact state it was in before you even started. It's all or nothing. It's an amazing safety feature for sure, but that all part, well, that can sometimes be the problem.
So let's dig into that problem. Let's look at a scenario where this all-or-nothing rule goes from being a helpful safety net to a source of total inefficiency.
Imagine a new user signing up for your service. We kick off a transaction. Step 1, create their account in the users table. Success. Step 2, set up their default preferences in another table. Also a success. But then we get to step 3, assigning permissions. And it fails. Maybe a key was wrong, whatever. The operation fails. And here's the kicker. Because step 3 failed, a standard rollback undoes everything. That new user account? Gone. Their preferences? Also gone. All that perfectly good, successful work just got completely erased. Now our app has to start the whole process over from scratch. It's just so wasteful. There's got to be a better way, right? And of course there is. This is where our hero, the Savepoint command, strolls in. It gives us that fine-grained control that we're missing. So what is a Savepoint? It's really simple. It's just a named marker, like a little flag you plant inside your transaction. It doesn't permanently save anything on its own, but it creates this special checkpoint that you can choose to return to if things go wrong later. Honestly, the best way to think about it is like a checkpoint in a video game. You know, when you finally beat a tough boss, the game saves your progress. If you fail on the next level, you don't start the whole game over, right? You just go back to that last checkpoint. A save point is exactly that, but for your database transaction. You get to undo just a part of it, not the whole thing.
Okay, so the theory is cool, but what does this actually look like in code? Let's revisit our user registration example and see how Savepoint changes the game.
Okay, take a look at this. We start the transaction like normal. We do our first 2 successful steps, creating the user and their preferences. Then, right here, this is the magic. We declare Savepoint before permissions. We give our checkpoint a name. So now, when that permissions insert fails, notice what we do. We don't issue a full rollback. Instead, we say rollback to Savepoint before permissions. This zaps us right back to our checkpoint, erasing only the failed step. And then we can commit all the good work that happened before it. This timeline just lays it out perfectly. We start our process. Then, at time 2, we plant our flag, our checkpoint, right after our initial successes. At time 3, disaster strikes. The failure happens. But it's okay. At time 4, our rollback to Savepoint command is like a time machine, taking us right back to the state at time 2. The user account and preferences are totally safe. Now, at time 5, we can commit that valid data and deal with the permission error separately.
So what's the big takeaway here? What's the real payoff for using Savepoints? Why should you care?
Well, it really all boils down to building more resilient systems. You get much finer control over your transactions. You're not stuck with that blunt all-or-nothing choice anymore. That directly makes things more efficient because you're not wasting cycles redoing work that was already done right the first time. It also opens the door for way smarter error handling. Your code can now try just the failed part again, or maybe log the error but still save the valid data. All of this together makes your entire application tougher and far more robust when it faces those inevitable little hiccups.
So I'll leave you with this question to chew on. Think about what you're working on right now, or your next big project. Whether it's a complicated data import or a multi-step setup process, where could a simple Savepoint make your work just a little bit smarter and a whole lot more resilient? That's the power we're talking about. Thanks for tuning in.